Good morning, everybody. Today we're just going to be practicing what we have done over the last 2 days with logarithms. So what I need everybody to do is first, you should have a blank piece of paper. And then you also are going to need some kind of scientific calculator that can do logarithms. So first we are going to practice with evaluating logarithms. That's what we did on Monday. So on your piece of paper, label 1 through 10. And then on your piece of paper, you are going to be evaluating these 10 logarithms. So you can go ahead and pause the video here and try these 10 problems. Hopefully it'll only take you a few minutes. Remember, when you're evaluating a logarithm, you're trying to find the missing exponent that you have to raise the base to. So pause here and then start the video again once you've tried all 10 problems. Okay, so hopefully you've tried all 10 problems. So what we're going to do is we're just going to check the answers for all of these. And then if you didn't get the correct answers, then you should watch as we go over them together. All right, so let's check. Number 1, log base 8 of 64 is 2. Number 2, log base 2 of 64 is 6. Number 3 is 3. Number 4, this one is a little tricky. This one is a 1/2 power. And number 5 is -2. Number 6, remember these first two, if they don't have a base written, but it says the word log, these are a base of 10. So number 6 is -3. Number 7, there's not an exact number, so we have to use our calculator to get a decimal approximation. And the decimal approximation is approximately 2.70 if you round it to 2 decimal places. Now, 8, 9, and 10, natural logs are all bases of e. But again, none of these are exact, so all of these last 3 we can approximate on a calculator. So natural log of 56 is approximately 4.03. Natural log of 2 is approximately 0.69. And then natural log of 0.87 is approximately -0.14. All right, if you got all of these correct, move on to the next problems. Just skip through the video till the next problems. If you didn't get these, then listen as we check over these. So remember, when we are finding or evaluating a logarithm, that we are trying to find the power that the base needs to be raised to. Let's go through these. So 1 through 5, we have bases of 8, 2, 5, 16, and 3. We cannot do any of those on a calculator. So these ones we have to figure out. On number 1, the base is 8. So when we're evaluating this, it means we're trying to find 8 to what power equals 64. That one, hopefully we know and recognize. 8 to the second power is 64. So that means the number we're looking for is 2. Number 2, the base is 2. And so this one, we're trying to find 2 to what power equals 64. That one we might not know offhand, so you can always use a calculator to try to figure it out. Let's see, if I try 2 to the 5th power, that's 32, not big enough. So then if I try 2 to the 6th power, it is 64. So that's what we're looking for. The power is 6. Number 3, we're trying to find 5 to what power equals 125. That power would be 3. Number 6, the base is 16. So on this one, we're trying to find 16 to what power equals 4. This one's a little tricky. It's not a fraction because, so I know it's not a negative exponent, but I also know if I do 16 to the first power, it'd be 16. So it's going to be smaller than 1, but not a negative number. Now, we talked about how a square root, a radical, can be written as a fraction. Hopefully we recognize that these are at least related, that we can do square root of 16 equals 4, because square root of 16 can be written as a power. That can be written as 16 to the half power equals 4. So the power that we're looking for on this one is a half. All right, and then number 5, the base is 3. So this one we're trying to find 3 to what power equals 1/9. Now we know 3 to the second power equals 9, but in order for it to be a fraction, I know it has to be a negative. So it's going to be 3 to the negative 2 power is going to equal 1/9. So all of those we had to figure out by hand because our calculator doesn't do any of these. Now, if we look at 6 and 7, these first two are common logarithms, which means they have a base of 10. So even though there's no base written, it means a base of 10. So number 6, we're trying to figure out 10 to what power equals 1/1000. This one, you can use a calculator, or you can also just kind of figure it out. Hopefully we know that 10 to the third power equals 1,000, but in order to get the fraction 1/1000, this would have to be 10 to the negative third power. Now, if I try to do number 7, I'd be trying to figure out 10 to what power equals 500. Well, there's no exact number because 10 to the second power is 100 and 10 to the third power is 1,000. So there's not an exact number, but hopefully we remember that we can do a common logarithm on a calculator. We do need a scientific calculator, and we just have to type it in, log of 500. And, whoops, I must have hit the wrong button. Log, oh yeah, I have to do 500 and then hit log on this calculator. So log of 500 is about 2.69, or if we rounded that up, it'd be 2.7. Now, these last 3 here are natural log. And so hopefully you remember on those have a base of e. And e is a number, that's an irrational number that's about 2.72. So this one we're trying to find e to what power equals 56. Well, we don't know because, again, e is an irrational number. But once again, all of these we can just do on our calculator. So again, make sure you use the correct button. This time we're using the ln, or the natural log. Declare what's in there. So natural log of 56 is approximately 4.03. On the calculator, natural log of 2 is approximately 0.69. And again, on the calculator, natural log of 0.87 is approximately negative 0.14. So 1 through 5, we'd have to figure out. 6 through 10, we could use a calculator for. All right, if you haven't yet, now let's move on to the next type of problems. Our next type of problems were changing between exponential and logarithmic form. So this is what we did on Tuesday. So remember, our exponential form was b to the p power equals a, and logarithmic form is log base b of a equals p. So whatever form the equation is in, we want to change it to the other. So if it's in exponential form, change it to logarithmic form. If it's in logarithmic form, change it to exponential form. All right, so now on your paper, on the other side or at the bottom, Again, label 1 through 10 on your paper. And I want you to try these practice problems. All of these, I want you to rewrite them. So whatever form it's in, change it to the other form. So go ahead and pause the video here and try these 10 practice problems. After you've tried the problems, then start the video again to check your answers. All right, so now that you've tried the 10 practice problems, let's check our answers. So these are all mixed up. Some are in logarithmic form and some are in exponential form. So whatever form it's in, we have to change it to the other. Number 1 is in logarithmic form, so I have to change it to exponential. In exponential, it'd be 2 to the third power equals 5x. Number 2 was in logarithmic form, so I have to change it, or sorry, number 2 is in exponential, so I have to change it to logarithmic. It's going to be log base 5 of 66 equals x. Number 3 changes to logarithmic, so log base 1/2 of 21 equals 3x. Number 4 is going to change to exponential. 7 to the 1.8 power equals x plus 4. And number 5 is exponential, so it's going to change to logarithmic. And so this one, pay attention to what number is the base. This is the base and the exponent. This is going to be log base 4 of 155 equals x plus 2. All right, so then let's change these ones. Notice these ones are some of our special logarithms. Number 6, it just says log, there's no base. So we know that this is a base 10. So in exponential form, this one would be 10 to the third power equals x minus 5. Number 7 is exponential with the base of e. So when I change it to logarithmic form, it's going to be a natural log. Natural log of 77 equals 2x. Number 8 is also exponential. Notice it's just in a different order. The base and the exponent are on this side, but the base is still e. So this one would be natural log of 4 equals x plus 1. Number 9 is exponential also, and it has a base of 10. So this one's our common logarithm. So when I write it in logarithmic form, I don't have to write the base. This is going to be log of 58 equals 3x. And number 10 is a natural logarithm, so that's a base of e. So this one is going to be e to the third power equals 2x plus 5. All right, if you got all of those correct, that is perfect. If you didn't, please continue watching as we make sure we know where all of these expressions are coming from. So first of all, we need to recognize what form it's already in so that we know what form to change it. Number 1, I know that this is in logarithmic form because I see that it says logarithm. So logarithmic form looks like this. All right. So this one is already in logarithmic form. So this is log base b. I like to label these log base b of a equals p. Okay, so label your b, your a, and your p. And now when we change it to exponential form, it's in the form b to the p power. So our base is 2. The p is 3, so it's going to be 2 to the 3 power equals a, so equals 5x. And that's what our expression would look like in exponential form. All right, number 2, this one, there is no logarithm. So I know it's not in logarithmic form. This one's already in exponential form. Okay, so this one's in exponential form. So this time, exponential, label your b, your p, and your a. This one is b to the p power equals a. And so then when I switch it to logarithmic, it's going to be log base b, so log base 5 of a, which is 66, equals p, which is x. All right, so that is now in logarithmic form. So obviously it should have a logarithm in it. All right, so that's what we're going to do on all of these is we are going to label, make sure we know what form it's already in, and then change it to the other. So if I look at number 3, there's no logarithm, but there is a base and an exponent. So this is the base and the power or the exponent. So the other side of the equal sign is the a. So if it's in exponential, I have to change it to log form. So that's going to be log base b, so the base is a half, of a, so of 21, equals p, so equals 3x. All right, number 4, this one is in logarithmic form because it says log. So this is in the form log base b of a equals p. So you have to memorize these and know these two forms so that way you can change between them. So when I change to exponential form, it's b to the p power. So 7 is the base, the p is 1.8, and that's going to equal a, which is x plus 4. Now, number 5, pay attention to the order it's in. This is still this is exponential. It doesn't say logarithm anywhere, but pay attention to the base and the exponent. This side is actually the base and the power. And so the 155 is the A. So it's not always written in the exact order, so just pay attention to which one is the base and the power. So when I rewrite this in logarithmic form, it's going to be log base 4 of A, so log base 4 of 155 equals P. So that's going to equal x plus 2. So those ones are just changing between the two forms. And we're doing the same things on these other side as well, 6, 7, 8, 9, and 10. However, these all either have bases of 10 or bases of e. So these are our special logarithms, either the common logarithm or the natural logarithm. So if we look at number 6, this is in logarithmic form because it says log. There's no base written here though. So we have to recognize that this is the common logarithm. It's the base of 10. So the 10 is our base, this is our a, and then the other side of the equal sign is our p. So when we change it to exponential form, it's going to be in the form b to the p power. So it's going to be 10 is the base to the third power equals x minus 5. Number 7 is exponential form. This is the base, this is the power, and this is the a. So originally, if we wrote it in logarithmic form, you might write it like this: log base e of 77 equals 2x. So log base b of a equals p. Now, we do have to recognize that this log base e is one of our special logarithms. A logarithm with the base e is a natural logarithm. So we would write that as natural log of 77 equals 2x. So the same thing on number 8. Pay attention though that this is not quite in the right order. On this one, we have 4 equals e to the x plus 1 power. Since we have a base and a power, this is the b, this is the p, and then the other side, this side is actually the a. So it's in a different order than number 7, but same kind of thing. If I wrote it in logarithmic form first, you might write it like this: log base e of 4 equals x plus 1. But again, instead of log base e, we would write natural log. So natural log of 4 equals x plus 1. So on both of those, 6 and 7, they were both in exponential with a base of e. So we had to write them in logarithmic form. A logarithm with a base of e is a natural log. So those both ended up being written as natural logs. All right, number 9, we have 10 to the 3x power equals 58. So this is the base, this is the power, this is the a. So this is written in exponential. So again, we want to change it to log form. If you wrote it in log form first, you might write log base 10 of 58 equals 3x. log base b of a equals p, but hopefully you recognize that this is a common logarithm, a base of 10. We don't really have to write the 10. So we can just write it as log of 58 equals 3x. All right, and then the last one is, it says natural log ln of 2x plus 5 equals 3. So this one, there's no base written, but we have to recognize since it says ln is a type of logarithm. So this is in logarithmic form. Natural log, ln stands for natural log. This is a base of e. So when I rewrite it, the base is e. So this is currently in the form log base b of a equals p. So the base is e, a is 2x plus 5, and the p is 3. So when I rewrite it, it's in log form, so I have to change it to exponential form, which is going to be a base of e to the third power equals 2x plus 5. So that one, I'm rewriting it in b to the p power equals a. All right, so those are our practice problems. Hopefully that was some extra practice, and then that helped you to be able to evaluate logarithms and change between the forms. So we'll stop there, so we're not doing any more of the notes. I just wanted to make sure we did some more practice with what we had done the past couple days. All right, everybody, I'll see you again tomorrow.